In this video, we're going to talk about carbon-13 exam style questions. Let's get on with it. So, is this statement correct? So we've got a student attempted to identify two esters. Here are the two esters. So stop the video, draw the esters and draw them out. Okay. Is it correct that you can differentiate between these two esters? So have a go and then let me explain the question. Let's move to the side. Okay, and let's literally draw them out. So I put that down here, right, and then let's have a look at these. And often it's easier actually to draw it in skeletal formula. So I'm going to draw it in skeletal formula. So first one, we're going to do A. Okay, and these are these two here. So you've got these two here, and this is the CH right there. Okay, and then that goes down to an ester, which is this bit here. Okay, and then the CH comes off this O, okay? So we're going to go down again, and this is a CH, and it's got two CH3s on it again. So two CH3s, I've drawn that, right? Okay, so that's good. Let's go for a different colour, just because I like different colours. Okay, and we can draw the other one. So the other one is almost exactly the same. Okay, let's do it here actually. Okay, and you go up like that. And then we can see that that goes down to the ester again. And you should practice doing these yourself. Okay, and then we go like that. And then we've got a propyl group coming off like this. Okay, that's 1, 2, 3. Okay, right, so we have got the two esters. Let's start counting the actual environments. So I always think this is the same environment. Okay, so that's the same environment. You see it's kind of symmetrical there. Okay, and then we have another environment here, and we have another environment here. Same environment again, and another environment here. So that means 1, 2, 3, 4, 5. We've got that. Okay, let's go to the next one. And we've got the same environment here again. Hopefully you're seeing a theme. Okay, we've got 3 so far, 4, 5, 6. Okay, so we can tell the difference because there's no symmetry in the middle of the molecule, so that means all of this is different. The only symmetry you have is at the end, these two groups at the end that are the same carbon environment. So if I show you the actual one, so it's possible to identify the esters because of 5 and 6. Okay. Going into a bit more detail, you can stop the video here and you've got these different groups that you can look at the data sheet and you can differentiate. But the main thing you can tell the difference is the 5 and the 6 carbon environment. So we're going to do another exam style question about distinguishing between different environments. So we've got to do one with benzene because benzene is a really tricky one. So we've got these 3. Phenylamine was reacted with dilute nitric acid, produced 2 nitrophenylamine and 4 nitrophenylamine. Okay, so, and you've got 2 and you've got 4 there. Okay, so 2 and 4 there and 3 there. So we've got 3 of them. So small amount of this is produced. So we've got 2, 3, 4. Okay, now explain whether carbon NMR can be used to distinguish between these 3 nitrophenylamines. Let's move it to the side and move it up and make it bigger. Okay, so first of all, I'm going to put rings around these to show just like I did in the last one, and I would recommend that you do that, and I'm going to do them in different colours. Now there's no symmetry here at all, so if I put a line down the molecule, this half is not the same as this half, which means you need to look at the carbons each side of the carbon you're looking at, and are they in the same environment, the carbons each side of any of these different carbons? So could I look at this carbon and have the same 2 carbons either side, this carbon, same 2 carbons in the same environment inside. And you can see there's no symmetry there at all. So all of them have different peaks, which means you'll get 6. Next one, there's no symmetry here either, okay, which means that you will get 6 again. But if we go for the next one, okay, we've got symmetry going down here, okay, which means, yes, they're different, but these two are the same as each other. So it's 1, 2, 3, 4. So you can differentiate, and this is really, really common. So being able to differentiate carbon environments when it comes to benzene, a really important thing. So 2 and 3 have 6 peaks. Okay, 4 has 4 peaks, And carbon NMR can be used to distinguish 4, which is this one, from 2 and 3, okay, but it can't distinguish between 2 and 3. And there's another distinguishing question which you need to get used to. So again, stop the video, try and do this one. Which one shows 5 peaks in its carbon NMR spectra? So we're going to go through now, again, with my coloured things. So what we can do is go, right, okay, here is your peaks, okay, and there you go, and there you go. And that's because there's symmetry down the middle. See the symmetry line? So the same environment, and there you go. So that's 4 peaks. Okay, let's go for the next one. So, go to C, this one, which is on B. Anyway, let's go to C. Symmetry again. So, again, same, then same. So let's go up again. Same. So we've got 4 again. Let's go to the next one. Symmetry again. So it would be same. Okay, same. Okay, and then this one. So this would be 1, 2, 3, 4 again. Right, so it must be D. Oh, it must be D. So let's go down and do it anyway. No symmetry. Okay, in terms of in the same way as the other ones, because it hasn't got 2 groups coming off it, but you can see it there in the same environment because it's got 1 group sticking off the top. Okay, and then you got 1, 2, 3, 4, 5, which is D. Okay, so as I've done with these, this is the last one of the distinguishing in the different environments. What I've hopefully proved to you is that you really need to get good at this for your exam. So in our final exam style question, we want you to generate a compound. And this is the thing, this is the really hard carbon NMR question, which can happen, and it can happen in a number of different situations. So we're going to give you one here. I'm not going to say this is an easy one, this is quite a difficult one. So unknown compound, empirical formula C3H5O2. We get 146 for the mass spectrum in the M+ peak. Okay, so first of all, we need to find out what the relative molecular mass of C3H5O2 is, and compare that to 146, and we'll do that slightly later. But even before we do that, let's look at the NMR. So here is your carbon NMR, and our first peak on our carbon NMR looks fairly sizable, and it's around about here. So you should be looking at the datasheet and finding out what that means. We have got another one down here, and another one here. Okay, and they're half the size of the original, which suggests that that is 2 carbons, that is 2 carbons, and that is 1 carbon each. Now, I've deliberately not told you where they are, so hopefully you're sitting there with a datasheet right now, looking at this video and going, right, okay, and you're working it out for yourself. You are not just watching me do this at double speed, okay? Try and work out what this thing is before I get to the end. Okay, so let's have a look at those. So I've put these because they're different types. So the one in orange is going to be your C double bond O, and it's worth 2 carbons, and these are going to be your CCs worth 2 and 1 and 1. Okay, and so you've got these. And if you were going to do this in the exam, you would have to say where it is and what region it's in. So it's at 170 in that region, which means it's a C double bond O, and it's these ppms in that region, therefore it's a CC. Right, so let's put it down to the bottom and keep the good information. So we kept our good information, which is that, the empirical formula, and the M+. Okay, now we've already got to the point, and I think hopefully you've already got to the point where you can see that 73 is that. Okay, 146 divided by 73 is 2, which means I need to times it by 2, which gets this molecular mass, which is 146. Okay, so we have got C6H10O4. So I think we have enough information now to actually draw this molecule. Now, first of all, I want you to get used to this and go think of it in the way I think about it, is you have got 2 carbons in the same environment and 2 carbons in the same environment. The other thing you need to look at is you have 4 oxygens. Okay, so you've got 4 oxygens. So what does that suggest? Well, that suggests that you have something, an ester, or you have a carboxylic acid. So I'm going to go for a carboxylic acid and just see what. So I have a carboxylic acid, and I have another carboxylic acid, which I think is in the same environment because they both create 2. So there's 2 carbons, same environment. Now I've accounted for this one, so I'm going to go to this one. Right, okay, I need 2 in the same environment. Well, maybe the carbon coming off this, they're both in the same environment, so there must be a line of symmetry down the middle. If there's a line of symmetry down the middle, okay, there's your line of symmetry. So your line of symmetry is bum, 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 like that, which means they are in the same environment, they're in the same environment. That accounts for 2 and 2. Right, I need a 1 and a 1. Right, okay. I've got a 1 here. Okay, I need another 1 to come off it. So why not I put methyl coming off the middle there? Okay, and I have my molecule, and that is my molecule, okay? So what you can do, and what you should do in the exam, is check it off against this formula here. So you should go, right, okay, 1, 2, 3, 4, 5, 6. Bang on, right? 4 oxygen, super. This is a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've got 10 hydrogens. Okay, so that is your typical question where you have to formulate a structure. Okay, so good luck, and I hope this video has helped you.